Welcome to the very first section of our AHIMA CHDA exam preparation course, where we are diving into healthcare data foundations and architecture. In this lesson, you will learn exactly where healthcare data comes from, how it is structured, and the critical systems used to store patient information safely. Understanding the foundation of healthcare data is incredibly important, because every analysis you perform as a certified professional depends on knowing exactly how this data is built. Get ready to explore the hidden architecture behind electronic health records and discover how millions of medical details are organized every single day. Let us jump right in and start building your expertise. And remember that you can always download our practice tests or use the offline app to reinforce these foundational terms as we go. The most common source of healthcare data you will encounter is the electronic health record, often simply called the EHR. An EHR is a digital version of a patient's paper chart, containing everything from medical history and diagnoses to medications and treatment plans. Think of the EHR as the central nervous system of a hospital, constantly collecting real-time updates from doctors, nurses, and laboratory technicians. For the CHDA exam, you need to understand that the EHR is considered a primary data source because it contains information recorded exactly at the point of patient care. Inside the EHR, data is generally divided into two main categories known as structured data and unstructured data. Structured data refers to information that fits neatly into predefined boxes or drop-down menus, like a patient's date of birth or their specific blood pressure reading. Unstructured data, on the other hand, consists of free text typing, such as a doctor's written notes or a detailed surgical report. While structured data is very easy for a computer to search and analyze, unstructured data requires more advanced analytical tools to extract meaningful insights. Another massive source of healthcare information comes from claims data, which is primarily created for billing purposes rather than clinical care. Every time a patient visits a doctor or has a procedure, a bill is generated and sent to an insurance company, and this formal bill is called a claim. Claims data includes standardized codes that represent specific diseases, treatments, and medical supplies used during the patient's visit. While claims data is incredibly useful for tracking healthcare costs and large population trends, it sometimes lacks the deep clinical details found in the actual medical record. When data is taken out of the primary electronic health record and put into another database for a specific secondary purpose, it becomes secondary data. A great example of a secondary data source is a disease registry, which is a specialized database that collects information on patients with a specific condition, like cancer or diabetes. Registries are incredibly valuable because they allow researchers and analysts to track the long-term outcomes of different treatments across a large group of similar patients. The CHDA exam often tests your ability to distinguish clearly between primary sources like the EHR and secondary sources like a registry. A core distinction you can actively practice and master using our offline app or practice tests to build your confidence. To manage all this information effectively, healthcare organizations rely on a concept called data architecture. Data architecture is essentially the master blueprint that defines how data is collected, stored, integrated, and used across the entire hospital system. Without a solid data architecture, a hospital's information would be scattered, disorganized, and completely useless for analytical purposes. As a data analyst, you must understand this blueprint so you know exactly where to find the specific information you need to answer complex business or clinical questions. The most common way healthcare data is logically stored is inside a system called a relational database. A relational database organizes information into tables, which look very similar to standard Excel spreadsheets with rows and columns. What makes a relational database special is that these separate tables are linked or related to one another using specific identifying codes. This means you can keep patient names in one table and their medications in a completely different table, but still connect them instantly when needed. To connect these database tables together accurately, relational databases use special identifiers known as primary keys and foreign keys. A primary key is a completely unique identifier for a specific record in a table, much like a patient's unique medical record number. A foreign key is simply that exact same unique identifier appearing in a different table to create a link back to the original record. Understanding how primary and foreign keys work together is crucial, because it is the fundamental mechanism used to combine different healthcare datasets. With thousands of tables and millions of rows of data, analysts need a map to understand what everything means, which is why we use data dictionaries. A data dictionary is a descriptive document that explains exactly what each piece of data is, how it is formatted, and what acceptable values it can hold. For example, a data dictionary will tell you if a patient's gender is stored as a full word, a single letter, or a specific numerical code. Always consulting the data dictionary is a best practice that prevents massive errors when you are preparing data for a complex analysis. To make healthcare data uniform and easy to analyze, the industry relies heavily on standardized clinical coding systems. One of the most important systems you will encounter is the International Classification of Diseases, commonly known as ICD codes. ICD codes are globally recognized alphanumeric codes used specifically to represent patient diagnoses and inpatient hospital procedures. By translating complex written medical diagnoses into standardized ICD codes, analysts can easily group similar patients together to study disease trends and treatment outcomes. While ICD codes focus heavily on diagnoses, outpatient procedures and medical services are tracked using current procedural terminology, or CPT codes. CPT codes are 5-digit numbers that tell insurance companies exactly what specific medical, surgical, or diagnostic services the doctor actually performed. Alongside CAPTAN, you will also see Healthcare Common Procedure Coding System codes, or HCPCS, which cover non-physician services like ambulance rides and medical equipment. Knowing the difference between diagnosis codes and procedure codes is a foundational skill frequently tested on the CHDA certification exam. When designing a new healthcare database, architects first create a conceptual map known as a data model. A data model visually represents the logical relationships between different medical entities, such as how a doctor relates to a patient and how a patient relates to a hospital bed. This visual mapping process ensures that the database is built logically before any actual computer programming takes place. A well-designed data model prevents data duplication and ensures that the system can handle future growth as the hospital expands. The standard tool used to draw these data models is called an entity relationship diagram, or an EHRD. In an EHRD, an entity represents a real-world object like a patient or a medication, while the relationships show how these objects interact with each other. For instance, an EHRD might show that one single patient can have multiple different laboratory tests over time, representing a one-to-many relationship. Being able to read and interpret an entity relationship diagram is an essential skill that helps analysts navigate massive and unfamiliar healthcare databases. As hospitals grow, they often generate more data than a standard database can handle efficiently, leading to the creation of data warehouses. A data warehouse is a massive, centralized repository that combines data from many different hospital systems, like the billing department, the pharmacy, and the clinical wards. Unlike a regular operational database that constantly updates minute by minute, a data warehouse is specifically optimized for running complex, large-scale analytical reports. By using a data warehouse, analysts can look at historical trends over many years without slowing down the primary clinical systems doctors use. A newer concept in healthcare architecture is the data lake, which serves a slightly different purpose than a traditional data warehouse. A data lake is a vast storage pool that holds massive amounts of raw data in its native, completely unformatted state, while a data warehouse requires data to be neatly structured before it goes in. A data lake happily accepts raw text notes, medical images, and unstructured sensor data. Data lakes are incredibly useful for advanced analysts performing cutting-edge research using artificial intelligence and machine learning algorithms. Patients frequently visit multiple different hospitals and clinics, making the secure sharing of data across different organizations incredibly important. A health information exchange, or HI, is an electronic network that allows different healthcare providers to safely share a patient's medical history. When a patient arrives unconscious at an emergency room, the HI allows the doctors to instantly access critical allergy and medication records from the patient's primary care clinic. Understanding the data standards that make this sharing possible is a key part of modern healthcare data architecture. The ability of different computer systems to connect and communicate effectively is known as interoperability. Achieving interoperability is difficult, because different software vendors often build their databases completely differently. To solve this problem, the healthcare industry relies on strict messaging standards like Health Level 7, commonly called HL7. HL7 provides a universal language format that ensures a lab result generated by one computer system is perfectly understood by a completely different electronic health record system. The newest and most advanced standard for healthcare data exchange is called Fast Healthcare Interoperability Resources, widely known as EHR. FHIR is a major leap forward because it uses modern internet technologies, similar to how your smartphone apps share data across the web. This standard allows developers to build secure healthcare applications that can pull specific, individual pieces of data from an electronic health record instantly. The exam often highlights FHIR as the driving force behind modern patient portals and mobile healthcare applications. Understanding all of these foundational elements gives you a complete picture of the complex healthcare data ecosystem. You now know how data is originally captured in the electronic health record, standardized through clinical coding, and stored efficiently in data warehouses. This structural knowledge is the absolute prerequisite for any advanced analysis you will perform in the field. Mastering this architecture ensures you will always know the strengths and limitations of the data you are working with. Congratulations on completing this first foundational section of the CHDA exam preparation course. To firmly lock in these new concepts, I highly encourage you to complete the attached practice tests right now. Or spend some time on our offline app to review these structures while they are fresh. Practicing with targeted questions significantly improves your long-term retention. And it is the absolute best way to measure your exam readiness. These vital practice tests and the companion offline app are included directly with this lesson to ensure your study routine is set up for success. Keep up this excellent momentum. Stay actively engaged with the material. And I will see you in the next section where we dive into data acquisition and management.